Section 8.1 is called polyphase systems. All that term means is multiple phases. We're primarily concerned with three phase, but polyphase in general is just a description in terms of, multiple phases of electricity. Now, there's nothing that requires this three-phase designation or construction system. It's sort of, as we go through this, we'll find out that three-phase, for the most part, is sort of this compromise or sweet spot trade-off where power can be supplied at the level it's needed without undue complexity, cost, and so forth. Now, a good analogy, and it's kind of interesting, and I'll tell this story primarily because I know a lot of you out there, you're trying to figure out what you're going to do and where you're going to end up and, what kind of job you're going to have and so forth and so on. You never know where you'll end up. I know a personal story for me, and I tell it and I try to relate it to this idea of a polyphase system. You can think of an analogy of say single phase electricity in terms of say a single cylinder engine. And you may have seen a single cylinder engine and used a single cylinder engine and not even, and I'm talking about internal combustion engine, and not even realize that's what you were using. But, basically what you have is, a single cylinder, and the best thing that I can think of to represent that would be, say, a gasoline powered trimmer that you might use, or a chainsaw or a blower, and it has one cylinder. And to get the power out that we need, it has to operate at very high RPMs, generally to keep the machine simple as possible. There's not a separate, oil system. So we combine the gasoline with the oil. And so long story short, we could think of a single phase, like a single internal combustion cylinder engine. And then we could have a two-phase system electrically, and that would be analogous to a two-cylinder engine. And onward to a three-phase system of which would, we could think of that in terms of a three-cylinder engine, or let's get up to six-phase electricity. We could have six phases of electricity, which would be the same as a six-cylinder engine. The analogy sort of crosses over there. So let's think about this, and let's look at this in a certain way. I want to give you an example of this, and we'll take this analogy as far as we can. Okay, so here's what we're just talking about. Polyphase systems are multiple phase systems, and this idea of phases and comparing that to internal combustion engines, or as they're known as ICE, internal combustion engines. And so if we thought about a single phase system or single phase internal combustion system, what's happening is the power is pulsed, right? It's coming from a single cylinder and it's pulsed, right? And how many times it fires, how many times that spark plug fires, that piston is moving and it's pulsing engine of power to the crankshaft or whatever, that we're thinking about there, and causing this, the action, to get the power out. So if we add a cylinder to that, then instead of it just being a single pulse, then it's coming in, multiple pulses, and they're timed to be synchronized so that they work together and they supply power, to this drive shaft, whatever's coupled to it, so, more power is available, right? Because it's not just a single pulse. And not only is there more power, but it's a smoother power. And then, take that to the next thing, to where we say we have six cylinders, okay? And then, you don't fire the six cylinders all at the same time, right? It's designed so that at each point there, one of the cylinders is firing and supplying power to the drive, and to whatever's coupled to it, namely the wheels. They get the power. And again, the more cylinders they have, the smoother this thing is. Now, I'll tell you a little story. Once upon a time, after I had been teaching math in high school after graduating from college, and I found out that public schools was not where it was for me, I had to get out of there and I wanted to do something different. And so I decided, well, I didn't really decide. I just, I just found myself in a place to where I had a friend that was in a different business. And, he was the sales manager for this company, and they sold a brand of power equipment called Echo. And so lo and behold, long story short, I became an Echo salesman. I got a station wagon and some um, demo units and dealer list, and lo and behold, I was an Echo salesperson. And the reason I bring this up, and when we're in person, we go through this a little bit differently, but we used to have these things called logging expos, and these different companies that manufacture chainsaws like Steel and Husqvarna, and back in those days, American manufacturer for McCullough, and gosh, I can't think of the other one, but there were two, Homelight, and so you'd go to these logging expos, and if you start a chainsaw, most chainsaws, they're single cylinder, 2-cycle engines, right? And so if you start them up and say, it's idling, and you put that chainsaw and you rest it on the ground or whatever, the power, it's pulsed, and there's a lot of vibration there, and that thing will just sort of, it'll move, it'll sort of creep around, because of that. But this was a saw that Echo made, which was unique, and I commend the Japanese engineers that worked for this company called Curitz that developed this thing, but it had opposing cylinders. And so there's two spark plugs on this thing. There's one here, and then there's one on the other end. And so what you end up with is a chainsaw that actually had twin cylinders. And two things that you noticed, first off, was it was a lot smoother. You could start this up and let it idle, and it hardly vibrated. It was smoother in terms of the way that the power was pulsed to the machine. And then the other thing that you noticed, for its size, it seemed to have more power than you would think. Now, there were problems with that. And we'll carry this analogy on through our electrical systems. With the added cylinder, there was an added complexity. And also what happened was, there was added weight to this thing. So this thing was released in 1986, and I don't know that there's since been another twin cylinder saw made. But the only reason I say this is, I'm trying to give you some examples and make this analogy of electrical phases and mechanical cylinders, and how they sort of there's an analogy there that we can look at. All right, so let's see. Is there anything else here? I don't know. I mean, I can wrap this up and say, if we carry this on, we can think in terms of, a three-phase electrical system. All the phases are identical, but what happens is, and of course this is all, sinusoidal. So here's a phase, and then there's another phase, and then beyond that, there's another phase, and all three phases, 1, 2, and 3, they're all identical that we're looking at. So, but the only difference is the phases are staggered from each other, and they peak at different times. So that when you look at these three phases, if this was phase 1, 2, and 3, notice that they have peaks. And these peaks, we're going to find out, are 120 degrees opposite of each other. And, so it's a system that allows us to, within the same amount of time, instead of, say, this is time across here, right? The same amount of time across there, we're getting more power to the system, through the system, by operating in 3 phases than we would in 1. Okay, so let's say that's the end of 8.1.